Hello, my name is Adabin and welcome to my talk about serverless, hopefully pragmatic Java, and with the title The Short Way to Serverless NoOps on AWS for DevOps Stage Conference. Okay, so let's start with the content. And first, that's fun. It was one of the, I think it was at the JCon conference. Someone asked me, how is the company airhacks? No, is it a good company? What is the the culture there? And there's no airhacks, so it's just a domain which I use airhacks live for my workshop, for instance. And immediately after the show, after the session, I registered airhacks.industries with all the links to resources. You will find GitHub, Twitter, LinkedIn, Blue Sky, and YouTube. And so I use Java all the time on the server and really enjoy it. And I started with Java, and since then I'm just using Java all the time on the server. And I also have a podcast, Airhacks FM, where I invite interesting people to have a chat. So usually I have no time at conferences. So what I do, I misuse the podcast to have a nice chat, right? So and for instance, I had a chat with Kelsey Hightower of Kubernetes about Kubernetes with the interesting outcome that Kubernetes was actually never meant to be used directly, and it was never used that you spend a lot of time writing YAML, for instance, and there are also other contents about serverless Java. So if you have any questions left, so once a month I'm answering all the questions on the AirHacks TV. This is a live stream. It runs already for almost 10 years, and so 8 years, and more than 8 years, because of more than 100 episodes. And what happens there is I'm gathering all the questions in a GitHub gist and answering the questions once a month. And so there's already a nice community. And what I got an idea to look back 100 episodes and then answer the questions from back then. And spoiler, usually these are the same or very similar questions I get now. I got, they are already answered almost 10 years ago. I also have a YouTube channel where I record daily Java shorts. And there are more than 700, almost 800 Java shorts. Is 1 minute with Java. Okay, these are the shorts, more than 650. And and there's a Discord channel. And if you're interested, I also, maybe once, twice a year, I organize online workshops. They were on Airport Munich, but since pandemic, it became global. So the next one is about single table design, serverless for serverless Java. And the other one is LLM Gen AI Java Foundation. And yeah, let's start with the show. So first, is Java suitable for the clouds? And this is one, I always show this slide because it surprises people. And what it is it is a study. So this is the URI to the study. And what is surprising, that Java does really well. So regarding energy consumption, and energy consumption is also similar to speed, to performance. So you see that Java is a little bit slower than C++, other Rust, and C as number 5. And if you compare it to Python, it is 35 times better than Python. And here's the same. So this is not the same. This is the execution time. So this is the performance, which is similar to the energy consumption. It's the same story here. Java is 189 comparing to 1 in C, and Ruby or Python are roughly 30 times slower. What Java doesn't do that great is with memory consumption. As you can see, it consumes six times more than Pascal and Go. And what's interesting, that C consumes more memory than Pascal or Go, which is surprising. But this is without GraalVM. So with GraalVM, Java will be a lot more memory efficient. And I assume somewhere, I don't know, in this area here. Okay. Now, why clouds, right? So first, I spent, I don't know, the first 10, 15 years, actually, almost until pandemic, just in private data centers, and then cloud happened. So the question is, why we are going to the clouds, right? So what is the purpose of the clouds? And if I ask these questions in if there are people, right? So not just online conference, if there are people in the audience, I ask the question, what is, if someone has no idea about a cloud developer, I ask, what's your idea about the cloud? What is your idea how we provision, for instance, database? And what people are expecting is like a button. You push the button, you have the database, you push the button, and you have the server. And this is, of course, not how it works, but this is the expectation. So for me, if we go to the cloud, we are not interested in, this undifferentiated heavy lifting, right? So we are not interested in the plumbing. We only would like to focus on business logic and leave behind all the infrastructure plumbing and XMLs, YAMLs, deployment descriptors, whatever, right? And for me, so this is what I would expect. And I think the closest to this idea is serverless. Because in serverless is exactly that. I just focus on business logic and I don't care about the infrastructure, and I am using managed services. They are just there and I use these services. So on that note, if I'm not interested in operating the entire stuff, so what is the best thing is to have so-called NoOps. And no operation, is a concept that an IT environment can become so automated and abstracted from the underlying infrastructure that there is no need for a dedicated team to manage software in-house. So this would be the ideal. And after deploying some Java stuff, we could talk about that. How close are we to NoOps? And I think in my production projects, we are almost there sometimes, right? It really depends on my clients. But sometimes if we go the puristic serverless way, there is not a lot to do to operate your applications. Okay, so the next thing is, I don't think there is any value if wrapping everything and abstracting from the cloud if you are in the cloud. I think it is better to have a very simple, to write simple business logic with simple code, with clean, simple, maintainable code without any abstractions. And if you have to leave cloud and go to another cloud, just to adapt to other cloud, I think it is faster than to write a framework around that and hope that it will abstract from the cloud-specific things. And some things are really hard to abstract, like access control, IAM, networking, and stuff like that. Okay, so everything in the cloud is about costs. This is the beauty. Why? Because the architecture is simple. Usually on premise, we had long discussions about, should we decouple modular architectures, hexagonal architectures, and modules, plugins, OSGI. Everything was possible. Sky was the limit. And in the cloud, we only have, one thing is it has to be cheap and maintainable. So on that note, motivation is, if we go to serverless, if we pick serverless with Java, how it looks like. So, and this is the AWS calculator, which calculates Lambda costs. And this is already a little bit pessimistic because we are assuming the average call duration is 100 milliseconds, which is usually quicker, you will see, then after deployment. And there's an ARM CPU, which is 10% cheaper and a little bit faster. And the surprising thing, what I'm assuming for enterprise, is that I'm running 2 transactions per second all the time, day and night. So this is the average load. And for that, I would pay 15 euros. And if there would be no traffic, I would pay nothing. So scale down to 0. Okay. Another interesting part is if I'm pushing Java, serverless Java, I'm not interested in building images, Docker images, or whatever. I would like to use things which are already in the cloud. So, and what I will gain out of that, for instance, this one, as Log4j issue happened, it was fixed by the Corretto team in the cloud. So if I would use just the AWS or Amazon's Corretto image, there will be nothing to do for me. So this is actually expectation of the cloud. Or I would stay, on premise. So now, if we go back here to the price, where is it? Here. Okay. So you see 2 transactions per second, 15 euro, which means if we have 20 transactions per second, there will be 10 times more, would be 150 euros. So what it means is the serverless in one point of time becomes too expensive. And if you will buy just, EC2 machine, it will be cheaper, of course. But especially for enterprise, this is the nature of boring enterprise applications. They are using a day and not at night. Vacations, they are just idle. So in such environment, serverless just shines because it uses a lot during the day and then we pay nothing. So, and why serverless is so good for enterprise? Because we get almost the perfect autoscaling, right? If you would use Kubernetes or ECS or stuff like that, what will happen is you will have to over provision your environment. So, and you will have to have, 2, 3 servers or pods running all the time. And if there's more traffic, you could start another one and over provision the another one, right? But in the case of serverless Lambdas, every call is like a small auto-scaling action. So the Lambda comes and goes and adapts perfectly to your needs. So we get precise infinite auto-scaling. So infinite is not really infinite. Usually it's 1,000 parallel processes per account, which are a lot. We can scale to 0, no traffic, no costs. And this is actually the biggest one, free developer staging environment. So Lambda costs you nothing. So you can very easily create, test, integration, prod environments, which cost you nothing per developer, which is impossible in Kubernetes. You will pay in Kubernetes case roughly 70 to 100 euros per control plane without having anything. It's just control plane and you don't even have a network, which will cost you at least 20 to 40 euros a month. So you get A/B deployments for free, rolling updates for free. This is what you get out of that. So it means it is you're just using and you don't have to care about that. Okay. So what we are doing with Java, and this is the unique thing, is we are building like the Lambda lith. So the interesting part is you can have a huge Lambdas in Java and they are still fast. So our Lambdas is sometimes hundreds of classes, and we basically don't care about amount of classes. What we are careful about external dependencies, jars, but we can write try to write, 1 meg of business logic. It would be a huge application. So what we also using is just stock microprofile, which is also interesting. So what is really easy is to port old J2E, Java-E, Jakarta-E applications to, there's nothing to port, it's the same code, but run old monolith applications on serverless. And the only thing is, we don't need a lot of APIs. So if you go to serverless, you will see in a second, so you don't need telemetry because, if you call the Lambda and you get metrics back at the other call, there's another instance. It doesn't make a lot of sense. Fault tolerance is the same. So you don't have to expose Lambda with circuit breaker, for instance. Maybe it should be optional fault tolerance because makes more sense from Lambda to call another external service via REST. You could use circuit breaker or timeout, for instance, but usually you won't annotate your own APIs to the outside world. Open API, usually it's the job of API gateway to expose Open API annotations and metadata description, and JSON Web Token authentication. Sometimes we can inject the token, but it is absolutely optional. Health check, I actually use health checks a lot with Lambdas, not to have a health check, rather than to have a defined ping point. And what we do, I return some configuration with the health check, and REST client is fully optional. What I use a lot is config. This is the ability to inject environment variables from Lambda into the application. And in core profile, we will find, for instance, JAX-OS, so we can expose multiple endpoints per Lambda, which also surprises developers. We can have as many external endpoints as we like. You are not limited to one function or one method. And how this works is the following. So you need a API gateway. So this is, for instance, in this case, it is HTTP API gateway. It can be REST API or HTTP API. Usually we go with HTTP API. It can be CloudFront. It can be application load balancer. And what I will use today is function URL, which is the cheapest and easiest, but also the ugliest, because the URI is cryptic. And if you would like to have a nice domain specific, or URIs which match your domains, you would use HTTP API gateway, CloudFront, or application load balancer. And how it works behind the scenes is fairly easy. So fairly easy. It is interesting, not easy, but understandable, right? So we have here a kind of gateway which is always on and is provided by the cloud provider by AWS. Function URL, gateway, HTTP API, REST API, CloudFront, or application load balancer, or VPC lattice. And it exposes a base URI. And what happens then is you call the URI the proxy, let's call it proxy, or the gateway here, whatever it is. It gathers the HTTP request and converts the request to an HTTP JSON event. And the HTTP JSON event is consumed then by the Lambda runtime, and it is passed to Quarkus. And what Quarkus does, Quarkus is really efficient, efficient. It is Quarkus consumes the JSON, and without reflection, it calls the JAX-RS endpoints, which are the same as they were 10 years ago in application servers. So there's no difference. So the application doesn't even know that it runs on Lambda. So what it means is we can pick the same code and run it if we like on ECS Fargate, on Kubernetes Fargate, or whatever you like, or even on my machine, which I will also do in a second. Okay, so this basically what was and what we do then for deployment. We pack multiple lambdas to one war and ship their war at once. And what happens then? We have multiple lambdas are deployed from the same. This is not a war, not an ear, it's a zip basically. So it just contains the zip, but it is built by Maven. Okay. Now, I hear a lot about platform engineering, but in this particular case, I mean, there is nothing to simplify. What platform engineering is, this also, why this on the slide? Because the entire trajectory, so the entire time we hear, application servers are complicated, it is hard to understand, they are not productive, and we need lightweight runtimes. Then we got lightweight runtimes, and then we say, okay, we have simplified things and be more agile and go to the cloud, And then what happened is, then it turned out that clouds are actually more complicated than assumed. And now platform engineering builds basically a platform which is kind of similar to application server, right? And what they do is they try to simplify cloud so that, developers can focus on business logic and not fiddle with the infrastructure. But if we go to serverless cloud, there is no infrastructure. So I think platform engineering is less needed. So of course, you need a kind of a template. But if you have the template, you can be very efficient and deploy your application to the cloud. Okay, now some code. And this was the last slide. So let's code a bit. And if you like, join my workshops. And so let's close that. And what I would like to show you is the following. So go back to, one template is AWS Quarkus Lambda CDK plane. I will use to deploy on serverless Quarkus and explain how it works behind the scenes. And what I prepared for today, the very first time, and pushed to GitHub is the corresponding pipeline. So it is very fresh, you see 1 hour ago. And what the pipeline does, it wakes up and deploys the template. So the entire environment is fully serverless. So unusual part is it tests my template. What you usually will do, of course, you would write your own pipeline, which tests and builds your application and not just the template, which is meta. And so let's see how it works. So this is my terminal, and in the terminal, I would like to set up Quarkus with Lambda with CDK AWS project. What it does, it clones this template, and call it DevOps stage. Yeah, why not? And it opens two IDEs. One is called CDK Cloud Development Kit, and the other one is Lambda. And if we take a look at the Cloud Development Kit, we will see the following. So in the POM, you see I'm using the AWS CDK library and the constructs and some JUnit tests in Java 21. And this is just basic Maven project, 60 lines of code. And how it looks like is the following. So here we have a CDK application. And what it does is it creates a DevOps stage app and adds some tags. And I created the infrastructure builder. And what it does, let's call airhacks. Let's change that and call it DevOps stage Lambda. And I would like to go with function URL because it's the quickest. But I could also decide to go with API gateway builder, for instance. And I created the builder for me because it's nicer to use. But if we take a look, what happens inside is the builder, just the function URL stack builder. We have here this template is actually not a toy. You could deploy to application load balancer, to API gateway, to CloudFront, function URL what we use right now, and every gateway ships with different configuration possibility. And for function URL, it is the easiest one, which is not a toy, but very suitable for conferences. And the other one depends on your setup. For instance, the application load balancer, you have costs which you have to pay all the time because you will need the VPC. But on the heavy load, it is significantly cheaper than API gateway, for instance. The API gateway is a little bit more expensive than the function URL, but you can have a proper SSL certificate and domain. And there are two flavors, REST API gateway, which is a bit slower and more expensive, but you can integrate with VPCs, and the HTTP API gateway is faster, but less capable. And the CloudFront one ships with best certificates, but is not really nicely integrated with function URL. And the function URL, what we use today, is just to explain you the principle. So what you use really depends on your profile, and you will pick one depending to save costs. Basically, this is the decision. Okay, so we have that, and now move to so this is the infrastructure part, and I ship both. So we have like one runtime, one application, and two parts. One is called Cloud Development Kit, and the other one is the business logic. And there is an interesting part. The business logic is actually has nothing to do with Lambda. If we take a look at the code, what you will see here is we have an application scope greeter, which is injected using @inject from microprofile, what you saw on the slides. And I'm exposing hello as get and post also hello. And there is a time to show you there can be multiple endpoints. So this time doesn't make a lot of sense, but you will see that you can also call the time, right? So now, if we go here, so what I can do is I can say Maven Quarkus dev and launch it. So I'm starting Lambda now on my machine, the Quarkus, right? Not Lambda, the Quarkus. The Quarkus just launches and doesn't know anything about the Lambda runtime. So now if I go to switch to browser, here's my browser, and say localhost 8080 / what was it, time, right? So I get the current time. So it seems to work. And I think it was hello Quarkus on AWS. So it is working. So now this works. And now let's try to deploy to the cloud. So for that, just double check. We have here airhacks DevOps stage Lambda. This sounds good. And so I would switch to, let's see, where are we? DevOps stage. And there's a script called build and deploy. Don't ask. And what it does, it builds both projects with Maven and ships to the cloud. Now we may ask, okay, this is magic. Oh, I have to update my Node.js environment. But let's see what happens. Or maybe before we see what happens, what I would like to do is build and deploy, don't ask. I'll show you what actually happens is basically 2 Maven invocations. First is the clean package with, first the function is built, and then the CDK is built and executed. And why I need the script at all is because of that, I would like to immediately deploy. Otherwise, it will ask, okay, I have these steps. Would you really like to perform them? It's like, yes. Okay. Now, so it deploys. It takes like, I don't know, 2 minutes. And after the 2 minutes, you have the complete environment. So this is the Lambda with business logic. And so with a little bit of luck, should work. 5, and that's incredible. So seems to work. So this is my URI, and now you will experience the first coldest cold start you can get. So this is the fresh deployment, and so just go there, and this is curl t is a macro which measures the performance, and now call the time, and let's see. And now I go, so the cold start was 3 seconds. And if we call it again, it is like 100, is below 100 milliseconds. So it means the 100 milliseconds on the Lambda level was really pessimistic. So now the Lambda is deployed. And what we can also do, so this, I just show you that it works. So this is the time in Frankfurt. And it was hello and hello Quarkus on AWS. So let's say I would like to change the configuration. And if we take a look at the business logic, so you see that the greetings boundary, the greeter, injects message with default value hello Quarkus on AWS, but the name of the property is message. So what I could attempt to do is, I could say, okay, that's nice. So what I could do is to pass the configuration, which is a map of, and it was message, and the value could be enjoy DevOps stage. Too many S's, but otherwise it works. So, and just redeploy the Lambda. Redeploy the Lambda. Where is the... And what will happen is the old Lambda is available and the new will replace the old one in place, and security is expired, which is a pity. So what I will have to do is to refresh the token. And for that, I have to black out you. Okay, I refreshed the token. So it is not a big deal because the token is only valid, I think, for 1 or 2 hours still, but you know, it doesn't look nice. So now I'm just rebuilding the application and hope the configuration get replaced. And what happens then, the message is put in the Lambda's environment, and it is injected to Quarkus, and I can just use it. And by the way, this will be the same process outside of serverless on Docker, Kubernetes, or bare metal. So after this round, we'll take a look at the actual code build or code pipeline, which is also interesting because it's also serverless. And what usually happens is the expectation is on every push to GitHub to private repository, on every push to the private repository, the entire application is automatically rebuilt and tested. But now let's focus on that, and it should be hello. This should be cold start again, and it is because it takes a long time. And you see, enjoy DevOps stage. This comes from the updated Lambda. Okay, so this was the backend serverless Java, and now how it is built. And for that, I show you another project. So let's close this one and this one. And what I have here is I have the Lambda CDK plane. And now what I will show you a project which is already on my GitHub account. And this is AWS Quarkus Lambda CDK plane code pipeline. And what it does is, this project, it is just infrastructure, so there is no business logic. And what this project does is, it installs a pipeline, a serverless pipeline, and I will walk through the code what happens here. So first, we create an artifact bucket. An artifact bucket is just a cache the pipeline needs to store the stuff. And so if we check here how it looks with Java, it's just one-liner. I say I would like to have an artifact bucket, which is private. Name is not needed. This is basically all. If you would like to have a bucket to access from your business logic, from application server or application server from Quarkus, is the same code. So okay, now I have the bucket, and what I need is Maven code build. Why Maven code build? Because the Maven code build uses a more recent ARM Linux and to have Java 21 support. And this nothing about Maven, but I use it for Maven. This is why I called it this way. And the one interesting part it uses a specific role so that the code pipeline is allowed to assume the CDK role. So the code pipeline is able to build the environment. And we are also using the log group, which is retained for 5 days, and then it just disappears. Okay, this basically it. This is the entire serverless pipeline. So now let's take a look how it actually works. And for that, I would like to switch to pipeline, and open that. And actually, it is already open. So this is the Quarkus CDK pipeline. If we take a look on that, okay, this is sign out. So go there. So, and this is my code pipeline. And AWS Quarkus Lambda CDK plane. So if I open that, you see there are two stages. The first one is checkout, and the other one is build and deploy. So if I would go to GitHub and change the template, this pipeline will run and then just go away. So I just pay per run. And this is what we do in the projects. Every commit to GitHub rebuilds the entire infrastructure and the entire infrastructure and also the entire business logic. So what means is, if I switch to AWS Quarkus Lambda CDK plane, and you will find it in this repository, and if I open this, in the root, there is one file called build-spec-YAML. And what you see here is what happens is actually the same what I did locally. What happens here is the business logic is built, and then the infrastructure is built, and then the entire thing is deployed. What missing here is in the stage that only happens in real applications is we have also system tests, and there is system test spec. So it means after the Lambda is deployed, it is immediately tested. So every commit leads to new infrastructure, new Lambda, and new tests. So there's the entire cycle, and the cycle takes, I don't know, 3 to 10 minutes. It really depends. CloudFront is the slowest because of the distribution and certificates, function URLs, and API gateways is the fastest deployment. Maybe application load balancer is a little bit slower because with application, it depends how you're doing this, right? Because if you will redeploy the entire VPCs and subnets, it's slower. If you have multiple stacks, it's faster. So, but the turnaround cycles for Lambda are really good. So, what I forgot to mention is one of huge benefit actually, is the following. If we switch to my pipeline, what you maybe saw is the following here. Here, bucket grant read and write pipeline role. So what I could easily do with my Lambda, I can say I would like to have a bucket, and the Lambda would like to access the bucket, and I will code the permissions like bucket, grant, read and write, and my function. So I don't have to write the policy statements by hand. I can code them. So if someone would like to review the security of the code, it is enough to look at the code. It is not necessary to take a look at the policy statements or the CloudFormation because it's fully generated from the code. Okay, so this is the pipeline, and now let's talk about maybe implement the bucket. So we have a few minutes left. Usually will be time for questions, but oh, what I forgot to mention is, or what I would like to take a look at is the actual Lambda deployment. So let's take a look at this, and so how this is working. So we have the function URL stack here, and here I'm using the Quarkus Lambda. So this is a simple Java class. So it is so-called construct with some optimizations, so garbage collection. But what's the essential thing is this here. What we see here is the following. I would like to deploy a function with Java 21, and which Java in particular depends on the cloud. And I would like to deploy from a zip file, and this is my handler, memory size, function name, environment. This is what I passed in the builder. And of course, what I could do here, I could, for instance, in the function URL stack, for instance, I could create bucket builder.create and say I would like to have a business bucket without the name, and say access control, or access control bucket access control, and this is private, and just build. This should be enough. The name is not necessary, and now call it business bucket. And with that, what I could do, I can say, hey, business bucket dot grant, let's say, read and write to my function. And now what happens behind the scenes, the bucket is created and the bucket gets access. Only the function will be able to access the bucket, no one else. And if the security changes, I will change this piece of code and rerun the pipeline, and then it will work again, right? So the interesting part is the entire infrastructure is coded. Infrastructure is code, so there is no manual clicks in the console are necessary. So this was about the serverless Java, what I'm doing in projects. So take a try. So it works really nice. And what I also forgot to mention is the entire infrastructure as code, CDK, is Maven project, so it is shareable. So what we do is you can create a jar, push it to your Maven repository, and you can reuse piece of the infrastructure across the entire enterprise, because your colleagues can just pull the jar and have the entire reusable infrastructure in place. And you can use the Java for the entire, from infrastructure to business code. So thank you for watching, and see you next time at conferences, AirHacks live workshops maybe, or if you have any questions left on AirHacks TV.